left off. So now we're gonna jump back into the instruments tutorial. And instruments again is a tool that you can use in Xcode to identify for memory leaks, any type of hangs that you might be having, or any type of hitches. So help to make sure that you know how the underworkings of your app is going. So anything under the hood, make sure performance as well. So the next chapter in this is hang basics, and the first thing is identifying a hang. So for this tutorial, so it says here for this tutorial guides you through recognizing a hang, using instruments to record it, and determining whether the hang is the result of a block or is of a busy or blocked main thread. So finally now it looks like we're gonna actually get into the code, and we'll actually be able to use instruments to find out how these errors are, how exactly hangs are occurring and what's causing them. So they recommend using Xcode 16 along with a device that's iOS 18. We're good on that, so we'll just skip through that. What you're gonna need to do though is download the project, and this is just gonna be like a starter Xcode project that they give you. I already have it downloaded here. This one's called initial version. And let's just jump back in here. And it says, so to start the section, the first thing it says is, the first section is experience a hang. So it says, learn what a severe hang during user interaction feels like. So to experience a hang, you run the sample app from the project files and try out its features. So we'll be able to, so I guess they added inside the project that we're going to download here, there is an app, and that app actually has a hang actually ready, so we can test with and kind of work with. So let's see what this replay does. Okay, so I guess they're showing us a hang here. So you see, let's start this back again. Okay. So I'm gonna hit replay, and you see it looks like the user taps it, and we wait a couple seconds, like 2 seconds, and then it actually toggles. Again, they tap it, and it's like 2 to 3 seconds, and then it's toggled. So that delay is a hang. All right, so the next thing it says is, and I love how Apple does their tutorials where they have this side here where you can actually see the SwiftUI code, and then the actual detail with the text or the instructions on this side. Makes it less boring, more interactive. So what they recommend for step 1 is connect an iPhone to your Mac, select it, Xcode's target, and then it says if this is the first time installing a development app on your phone, you need to enable developer mode. So yeah, you need to turn this on. If you've been developing for a while, you probably do already have this on. If not, just click on this link, enabling developer mode on your phone, and you can just follow these instructions. Pretty much you turn it on in settings on your phone. Let's just jump back. Anyway, so the note that they gave us is always take performance measurements on a physical device. So if you're using instruments and you want to check the performance of the app, they recommend using a physical device versus a simulator. And it says the reason for they prefer this is because as a simulator can have different performance characteristics, the bug in this specific example isn't sensitive to processor use, so you can also use an iPhone simulator. All they're saying is they basically, for the project that we just downloaded, even though they recommend using a physical device in the general world, for the project that we just downloaded, it's handled where you can see a hang using a simulator. So you can just use a regular simulator. But probably if you're working on like some task on your team, they recommend using a physical device. All right, next thing. So the next step is, so let's actually do this. So it says connect the phone. Let's open our project. So let's minimize this. We're gonna go inside initial project, starting point, and then we're just gonna click the Xcode project here. And because it's outside, we have to click trust and open, and it's from Apple, so yeah, you know this is good. Right now it's set to my physical device by default, but like we mentioned, for this scenario, we can use simulators, so I'll just change this to iPhone 16 Pro Max. I'm gonna keep Xcode here, and let me see if I can. You might need to make it smaller, but we'll see. Let's make Xcode a bit bigger. All right, that kind of worked. And next thing it says is that once we launch it, they want us to set the simulator. Next thing is in the toolbar, click the run button. Xcode builds and installs and opens the app on your device. So we're just gonna run it, and then it says wait for the app to launch and show a list of image file names grouped by category. So before we even get to step 3, let's just run this. So we'll jump back to Xcode. I'll just hit run. Hopefully it doesn't take forever to run since we've never run this project before. Our simulator is launching. So let's see what Apple gave us. Thought it was gonna take a bit longer than that. Maybe I was right. Okay, it's still taking it. Scroll down a bit. And it says wait for the app to launch, which is what we're doing now, and show a list of image file names grouped by category. So that is this right here. So we're seeing so it says these are a list of image file names grouped by category. So the category is like city. We have a category for flowers. We have a category for food. You can tell by here. And other category, we have a category for landscapes. And then probably there's some other category, but you get the point. And now for each of these, within the rows for each of these categories, they said these are image file names. So all these are just some image file names. Let's see what they say to do next. So scroll in the list, tap to select an image, and then tap the back button to return to the list. Notice that there is no perceivable delay when interacting with the app. So I guess this part is fine. They just want to show us that we can do this. So let's tap it. And then if we tap back, nothing happens. It's pretty much instantaneous. Like there's no delay, no issue there. So let's scroll down. And said the hang occurs when switching to the collection tab. So this is the collection tab. And it says for step 4, tap the collection tab and pay attention to what happened or doesn't. Notice that the app doesn't seem to react when you tap the collection tab. It takes about 5 seconds, and 5 seconds is a long time for an app to respond to anything that the user interacted with. So for the app to react before it displays, blah blah. Let's just see how this works. So it says tap the collection tab. So I'm gonna tap this now. 1, 2, 3, 5. So it took me around 8 seconds to actually get to this tab. That's a huge delay. And then the next thing says Apple says it takes 5 seconds for them, but for me it was 8 seconds. So the next thing is it says return to the list tab and then tap the collection tab again. The hang doesn't recur in this app. The hang only occurs the first time you tap. So if I should go back to this and then I tap collection again, yeah, just like they said, we do load up we actually get pushed to the view right away. So there's no delay. It looks like the delay that you mentioned only happens on the first interaction with that tab. So let's see. So it says this is the experiment. Run the app a few times from Xcode and tap on the collections tab. See if you can reproduce the hang. Not only does the hang, we already know we can reproduce the hang. We just did it, wait, only for the first time. So whatever. So not only does the collection tab not activate for a few seconds, you can't interact within the app at all during that waiting time. The app is completely unresponsive. So this part we didn't kind of see. So not only does the collection tab not activate for a few seconds, you can't interact with anything in the app. So we can't do this right now because it says it only happens the first time. So let's rerun the app. And when we tap collections tab, what we're going to do is try to see if we can tap anything else on the screen. I'm going to tap it. And I'm trying to tap a rows and I still can't. Say blocks that completely blocks the UI. All right, so we do see this happening then. And let's just make sure that if we go back and click on it, yeah, it starts working. All right, so not only does the collection tab now, it ruins the interaction. Okay. So now for section 2, we're going to be finding a hang using instruments. So this is like the real good part. We're going to actually dive into using instruments, which is what I've been waiting on. It says, now that you have what a hang feels like, you can reproduce it. Profile the app with instruments to see how it shows the hang. So I guess we're going to be using instruments now to like kind of see how if we can visually see the hang in Xcode Instruments. And it says you can also use instruments to find shorter hangs that aren't as obvious as the one in this example, or to find conditions that are likely to cause a hang. All right, cool. So we can use it to find some really, really long delayed hangs or hangs that might be pretty shorter. So maybe like 3 seconds. This one was like 8, so maybe we can find ones that are like 3 seconds, maybe even 2 seconds. So, and it depends on what the app is. You know, if you download some huge data or whatever, but you don't want a bad experience, so you should definitely do this. So the next thing is, it says in Xcode, click and hold the run button, then choose profile from the pop-up menu. This starts a profile build in Xcode and changes the default action of the button to the profile action. That was a lot. So the first thing it says is hold down, click and hold on the run button, and then choose profile, which will be this. So when we hold down, so let's just stop our code right there. So let's do this. So we'll hold down on the play button and then hit profile. Building 2944. Okay, so we get that instruments pop-up window here. And I see this now, this new app, and this is instruments. Automatically, I guess time profile is handled or is highlighted, but let's see what it says. So we did this portion. Now it says this starts a profile build in Xcode, which is what we saw when we saw that building, and changes the default action to the button, default action of the button to the profile button. Oh, okay. So notice this isn't even the play button anymore. This is just their profile button. Okay. Next thing, put this back up here. It says, note the profile action builds your target in release mode. Okay, so running that profile button builds the target in release mode. And it said, as debug builds can have different performance characteristics than release builds. So the reason it looks like they're saying that it ran it in release mode is that there are certain features or processes that happen only in release mode versus in debug mode that might not happen. And honestly, this is good, I guess, because when your app is in the App Store, that's the release version of it, not the debug version. Okay, so we can say next, you can also invoke the profile action by choosing Command I. Okay, so that's just a quick way to do it. All right, so next, after Xcode builds your target, it opens instruments configured to the target selected. So right away, we see it opening here. And then it says wait for instruments to open and show its template chooser window. Yeah. Choosing a template here creates a pre-configured document with instruments already added to it and that are well suited for a specific task. So basically when we click it, we're gonna get like some document ready for us. Pretty much like a template, I'm guessing. And now for step 3, it's confirm that instrument targets the image viewer app. And that's the name of this entire app, image viewer here. This image viewer here. And then I'll add this back. And it's confirm that instrument targets the image viewer app on your device. Then select the time profiler template in the list and click choose. So we'll click on time profiler here. And you can see it looks like these are all different type of instruments for different things that we might want to check, but let's just go with time profiler. Choose. And we get this window. And this is still this instruments app right here. The next thing it says is this creates a new document with a set of instruments, often used for time-related profiling. So this is our new document, and I guess we're going to be using this for time profiling. Okay, so it's a tip. The time profiler template is a good starting point if you don't yet know what you're looking for and sluggish, and something in your app feels sluggish. So if you're not sure what exactly, if it's a hang, if it's a hitch, or some type of problem, or what the problem might be, they recommend starting with the time profiler. Okay. So for number 4, it says take a moment to familiarize yourself with the instruments window. I don't really know how this works, so it's odd to kind of familiarize myself, but let's see. It looks like we have time profiler here, which is the one we selected. And it looks like these are some settings for it. Oh, for each type. So there's some type of point of interest, and that got highlighted when we clicked on it. And then there's something called a thermal state. It shouldn't that be heat? Can we track heat from Xcode? If we can, can we track the heat of our device from Xcode? If we can, that is sick. Big up Apple. And then it looks like there's something else called hands here. So are all these? I'm not sure why it added these two here, or even the hangs on, since we want to check hangs, but we didn't specify that. But we did expect the time profiler. All right, cool. I have to try to familiarize myself with that. So it says, when you create a new instruments document, you start out in the next recording view. Okay, which is this. Alright, when you start with the next recording view, this is where you configure what data to record by choosing a set of instruments to record the data with. Oh. Choosing a set of data to record the data with. Alright, tip. The template you choose in the previous step determines which instruments are added by default to the new document. Oh, okay. So because I selected time profiler, I guess that's why I got these other 3, excuse me, instruments. Okay, cool. Time profiler gives us a point of interest, thermal state, and a hangs instrument. Okay. You can always make changes afterwards and even after recording a run. You can come back to the next recording view to make changes to the next recording. So we can make any type of edits that we want to make. Say, I guess that's to like any of these instruments. Okay. So each entry in the list represents a separate instrument that gathers specific data when recording. So I guess the time profile one gets some certain type of unique information that it can get. These recording settings. And then the points of interest one records some type of unique information it can get, followed by others. I feel like I really want to hear about thermal state because I want to see if we can really track the heat of the device from instruments. Or the heat of the expected device if you're trying a simulator maybe, or maybe it has to be running on physical. We'll see. The running option. Right, okay. And then these, and then it's, each instrument can have recording options on the right. So these are all their options. So each instrument are listed here, and then all of their options. The time profiler has these options, and points of interest has this option, and then hangs has a bunch of these options here. Now we'll say the default list of instruments provided by the time profiler template and their default recording options are suitable for this use case. All right, so it says click the record button to start recording data. Instrument starts recording and launches the target app. So once we click this, we'll start recording like all our data in the background, I guess. And then let's look at their preview. So they hit it, and then here it's just that. So when recording starts, Instruments creates a new run, displays it in the sidebar over here, and selects it. Instead of recording option, the content area for a selected run displays a track area at the top with a detailed view at the bottom. All right, so let's do this. Let's read this one. And then the next piece is each instrument transforms to a track that spans the whole width of the track area. As soon as data starts coming in, a fifth track appears showing the combine. Okay, let's run this and then actually like do this and see how it goes. And then we'll reread this. So the first thing they said is wait for the recording to start. When recording starts, so yeah. First, click the record button to start recording. So you hit that. Okay, and we did instantly see this change. So next thing is there a recording. Wait for recording to start. When recording starts, Instruments create a new run. Yeah, displays it in the sidebar and selects it. So I guess this is the sidebar that. Oh no, this is a sidebar, and it creates some new runs. So I guess that's tracking each recording that we're doing, and then it says instead of the recording options, the content area of a selected run displays a track area at the top with a detail view at the bottom. Oh, okay. So for each of these instruments now, we have, you see this track area that we have. That's each of them. So before we were just seeing the options to do it. If I click on next recording, we'll yeah. So before we are just seeing this for each of them. But I guess once we start tracking our recording the behavior of the app, those instruments that we added, we can do different runs like whenever we're measuring the performance, and we'll get a new track over here. So a time profiler, our first track is, I guess, is this one. And you see there's some stuff being done by the CPU. Point of interest looks pretty blank, and then there is another track for image viewer. And then it says the track at the top with a detail view at the top. So this is the run. There's a track area at the top. So that's the one that we were just looking at. And then with a detail view at the bottom. Oh, so this must be this. So I will. Doesn't look like I can. I was hoping if I zoom in on this, but it doesn't look like I can zoom in on instruments. But pretty much it's saying, if I can zoom in here, it's just affecting our track. So this must be the detail view. See if it changes based on what instrument we pick. Oh, it does. So if when I click on time profiler, our detail view down here at the bottom changed. So let's click point of interest now. Hangs deep image viewer. See some work. Alright, cool. So the next thing, this it says each instrument transforms its track that spans the whole width of the track area. Yeah, we see this. As soon as data starts coming in, a fifth track appears showing the combined information for your apps process. Okay, so this must be this. This is the fifth track that appears showing the combined information of your apps process. So let's click that down and see what this is saying. See something that says main thread, so maybe this is the main thread. And they say it's the combined information of your apps process. All right, let's scroll down, and it says scroll in the image list in the app on your iPhone, and notice how the displayed CPU usage in the time profiler tracks changes during okay, so it says scroll in the app in the image list on your iPhone, and notice how the displayed CPU usage in the time profiler track changes during the scrolling. So it looks like we have to start recording again since I just stopped it. And oh, didn't stop it. Let's delete this run. This should be fine. And let's just do our run again. Oh, it called it run too. Let's just change it back to run one. And then we'll go inside our app, and it says scroll to the image list on your app and notice how the CPU display in time profile track change. Okay. So go to our image list and let's just scroll. We do see some stuff happening here for time profiler, CPU support. Just to make sure, let's click their replay. So they started scrolling and they started seeing some updates to just their time profiler and their image viewer. So we're kind of seeing that, so yeah, that's good. And then it's a reproduce the hang by tapping the collection tab in the app again. After the hang is over, stop recording. Instrument draws a large red rectangle that indicates the start time and the duration of the hang. It's going that there replay. They look like after they clicked it, we see this huge red box. And I guess that represents the hang. All right, so note Instruments uses several different graph types. For example, the time profiler tracks displays the CPU usage as a bar graph. Time profile as a bar graph here. Whereas the hang track uses rectangles to indicate the intervals. Oh, I guess those big rectangles. All right, so let's test this out. We're gonna stop our instrument, this one, and I'm gonna delete this one, and we're gonna add one more. So the first thing I'm gonna do is pretty much just see if we can check the record what happens after we click that collections tab. So inside our app right now, you see instruments is recording. We got some process here. Now let's click collection. Let's see if something changes. Oh, I instantly see this block here appear, and that represents hanging. So let's just stop it. I will immediately see inside for both of them what I'm seeing here. So for time profiler, I see a lot of CPU usage, almost 91, 110% inside time profiler. And then for the hangs, we see something here that says severe hang. And it says 5.91 seconds. I wonder if that means the time. More like I think that means the time it took to hang. Let's look back at the tutorial. And it says reproduce the hang. Instruments are large red. So it says stop recording. Instruments draws a large rectangle in the hangs track that indicates the start time and the duration of the hang. So yeah, so this represents a hang that we saw when we clicked on the collection tab. And it's here, it started at, I guess, 0.9. It's kind of hard to see because it's small. And then it stopped at 15 seconds. And then it says instrument uses several different graph types. For example, the time profiler track displays the CPU usage, which is this. Time profiler track displays the CPU usage as a bar graph, whereas the hang track uses rectangles to indicate the intervals. So the hang track is this. I say it uses rectangles to indicate the intervals during which a hang occurs. So whenever a hang happens, this track here will show where the hang is using these type of rectangles. But for the time profiler, we use like a bar graph. So you can see how busy this is. And like if I run my mouse over it, it's showing, I guess, the percentage of CPU that it's using up. Okay, so let's scroll down. It says move the pointer over the red rectangle in the hangs track to display tooltip with the exact duration. So we kind of did that before. Let's do that again. When I put my pointer over this rectangle, with for mine it says 5.91 seconds. Apple it's saying 4.6. When you do it, it might say something different. I guess it might be based on your machine and probably the simulator. All right, next thing is, in this example, the hang duration was almost 5 seconds, which is a severe hang. And ours is 5.91 seconds, which is still a severe hang. They said the exact duration of the example depends on the process. Okay, see there? The exact duration of the example depends on the processor on your test device and the system conditions while you're testing. So if you're using a really, really fast machine, you probably will see a shorter hang. The hang will probably still occur, but it will be shorter. So I'm guessing whatever Apple was using here for 4.6 was probably a really good machine since it's Apple. Versus mine, which is 5 seconds, since I'm just using a regular machine, regular MacBook. So next thing, the exact duration of hang, yeah, between my test. Okay. For step 10, now it says choose view and then zoom to inspection range. It says instrument scales the recorded data to fill the entire window width, making it easy for you to analyze the recorded data. So let's run the replay and see what they mean exactly. They clicked on view, zoom, run it again. So they clicked on view and zoom to inspection. range one more time. Zoom, zoom to inspection range, and then so it actually expands. It expands so you can see the full issue completely. Let's try that. I'm gonna click on time profiler. Then in instruments, view, then we'll say zoom and zoom to inspection range. Oh, and it actually does expand to, it looks like it's focused just on where the issue is. Okay. And now it says, let's read it. So instrument scales the recorded data to fill the entire window with, yeah, that's what it did. Making it easier for you to analyze the recorded data. Cool. This is a better way how you can look at and focus on the data. Say if if you did like a long recording to try and track the issue. And says now is a good time to save your document in addition to naming the document. You can also change the name of a run by double clicking it in the label. We did that before. And entering a new name. In later tutorials, you add more recording runs to your document. Renaming the runs with specifics about the conditions or performance issues make it easier to differentiate between them. So if you want to do multiple runs, you can rename them. Say if you want to test if a hang is happening in your home screen versus your profile screen, you could create a different run recording for that. Uh, and it says sometimes recommended that you do it based on, if not you're doing it by screen, maybe the type of check that you're doing. Maybe you're checking for a block main thread or something like that. Tip: to see even more of your data, click the hide sidebar button in the toolbar. The name of the currently selected run appears in the toolbar, even when the sidebar is hidden. Subsequent tutorials keep the sidebar hidden to maximize the space of the data. So let's see. To see even more of your data, click the hide sidebar. The hide sidebar button in the toolbar. Hide extended detail, is it this? Show extended. The name of the currently selected appears in the toolbar, even when the sidebar is hidden. Hide sidebar here. Oh, maybe this? Oh, okay. So we just tap that and we could hide the sidebar over here. Ah, cool. Subsequent, alright, so it's the name of the currently selected run appears in the toolbar, even when the sidebar is hidden. Okay. Subsequent tutorials keep the sidebar hidden to maximize space for data. You have successfully recorded a hang in the instrument and can now analyze it. So now we're at the third section. And now this is saying, so yeah, we have identified it, which is this. And now it says determine whether the main thread is busy or blocked. And just as a reminder, they gave us a quick visual here. And again, when the main thread is busy, that's when we're doing so much work on the main thread that the CPU is taking up a lot of space. That the CPU is doing a lot of work. And then when it's blocked, it's when we're having a lot of work done on the background threads. But then the main thread becomes basically not doing any work. So from this, I would guess that this is gonna be a busy main thread since we have so much work being done, and a lot of when I'm running my mouse across it, I'm seeing like 100%, 90, 116%. There's a lot of work being done on the main thread here. Let's see what they say. So they said, now that you've found the hang, you'll need to examine the amount of CPU usage on the main thread. High CPU usage means that the main thread is doing a lot of work, while very little CPU means that the main thread is blocked. So just like I mentioned, so you see a button, if you see this, which is high CPU usage, means the main thread is busy, and you see this huge block or gap here, that means the main thread might be blocked. Excuse me. So it says if CPU usage on the main thread is high during the hang, you'll need to look at work being performed on the main thread, which is what we're seeing. However, if the CPU usage on the main thread is low, it's not worth spending time explaining what's running on the CPU. Instead, investigate the causes of the thread not to run. So that would be the block case here. All right, so it says the last track in the instruments document shows the process track. As the last track in the instruments document shows the process track of the target process or processes. Processes tracks often have subtracks. As the track has subtracks, there is this closure triangle between the track's icon and its label. So it looks like this is what they're talking about. And it says the first thing is the last track in the instruments document, which is this, shows the process track of the target. So it shows the process track. Okay. And we do see process pretty much listed here. This is the process track or processes. Process tracks often have subtracks. It says when a track has subtracks, there is a disclosure triangle between the track's icon and its label. So let's see. What are they referring to? Next thing is step 1. Click the disclosure triangle on the image viewer track to reveal the subtracks of the for this process. So I just clicked that and we're seeing, so now we're seeing all the subtracks for our image viewer process. Let's look at their, let's read this out. In this case, the subtracks of the process tracks are thread tracks. Subtracks of the process tracks. So all of these subtracks here are thread tracks. And you see the name listed here. So thread, 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 and then we have one called main thread. I guess this is the category that of type of subtract that they are. All right, there's one track. There is one track for each thread. Okay, existed during the time instruments recorded process. So each of these tracks, subtracks, were a thread running when we were running the app. Interesting. So we can see literally every track, every thread that was running as a process after the recording. All right, so there is only one process track because Instruments is targeting only one app in the setup. Okay, so for each app, you basically will have a process track, and pretty much that's gonna be pretty much the actual app. So if this is called, say, social app, the process would be social app, because our app is actually called image viewer. Okay. All right, Instruments is also capable of recording every process on the system, in which case there would be one track per process. So I guess we could say if we were running Instruments on the map book itself, you'd probably see a bunch of different processes representing each of the apps that I actually have. I guess can we do that? Oh, okay, so if I probably run, say if I was using my physical device, I could do that. And I could see probably all the processes for representing for each app on my device that I'm running. We can test that out in a different separate stream. But let's run this replay. Let's just see how Apple is doing it. So they tap the arrow and pretty much for our process, and then they could see all the subtracks for all the representing all the threads that were being used by the app during that recording. The main thread is the most important thread for analyzing hangs, definitely. And we see the main thread listed here. If I press the down arrow again, move this up, I see the main thread right here. And it says that's the main one. Okay. Instruments displays it at the top. Yeah, I know. I see it. And then for experiment, it said most of the other threads are generic worker threads. See if you can find the thread that's used to fetch input events from the Windows server. Input events from the Windows server. I don't see any of them with any specific name. So it's if you can find the thread that fetch input error. I wonder if that would be the main, since that's where we get user input. Not sure. So anyways, next you'll focus on the hang duration itself. So it says control click on the severe hang. Control click on the severe hang interval in either of the tracks and choose set inspection. And then from the contextual menu, what will this do? It says this applies a time filter to the track area. By setting inspection range from the hang interval, it extends from the start to the end of the hang. All right, so control click, let's do one step by step. So control click on the severe hang interval in either of the tracks. Also, we can do it from this hangs track, or we could do it from our image viewer track. Let's just do the hangs track. And so control click interval in either and click set inspection range from the contextual menu. Oh, and it looks like just like we see like this filtering, so it's kind of focused on just this hang area. Cool. And like it's kind of ignoring everything else, so like the thermal state, all of that stuff, and we just like it kind of blurs it to kind of grays it out, so we can really just focus on this area. Sick. All right, so this applies a time filter to the track area. We see that. And then it says by setting the inspection range from the hang interval, which is what we did, it extends from the start to the end of the hang. Yep, we see that. So click the main thread to select it. This combines the focus on one thread, time filter on the hang interval. See what that is. So let's click the main thread. And it says this combines the focus on one thread with the time filter of the hang interval. So it looks like we can, so within this thread, we're seeing how it links with the hang instrument, and it's focused on it. So we see the CPU usage for during this hang on the main thread, and it's like really high. Some of them are 100, 90, 93, pretty high. Okay, and let's run our replay again just to be sure. So they clicked it, and now they could see it. Okay. All right, so the main thread track displays a graph showing CPU usage over time. And we see that here. Kind of just ran through that. So it says, move the mouse pointer over the CPU usage graph in the main thread track to display the CPU of the thread. I think this is what we were doing earlier when we were kind of just running my pointer over it, and I'm seeing different like percentage. Let's hit replay. Oh, they're testing like outside. Okay. Okay, so let's try outside too. So it's pretty low here. There was some point where it did touch 100, but it looks like it's really and a couple tens. But once we get into the track that we're focused on, where the hang started, see it shoots up to like 90, 80. It doesn't go below even maybe 80%. That's still pretty high. So it says a specific thread CPU usage can be at most 100%. And most of these were like 90, 70, 80, meaning that it used 100% of a single CPU core at time of measurement. It's using up a lot of work. The CPU is doing a lot of work. However, the process track combines the CPU usage over the whole process. However, the process track combines the CPU usage, process track, which is this here. It combines the CPU usage over the whole process. And because a process can have multiple parallel threads, total CPU usage displayed in a process track can be much higher than 100%. Okay, can have multiple parallel threads. Okay, so you'll see some cases where you'll see like 110%. You might see 109% or something like that. Now it says For example, if the CPU usage is 200%, that means the process is using the equivalent of 2 CPU cores. Because remember, if we use 100, the max CPU each core can have is 100. So if we're using 200, we're basically using 2 cores altogether. Let's run our replay here, and we'll see that, yeah, again, they're just comparing the CPU time and process time, both outside of the filter that we have and inside of it. Now it says from the CPU usage graph in the main thread, tracked during the hang interval, you can clearly tell that there is very high CPU usage during the hang. Yeah, we saw that. This is a busy main thread hang. Yeah, because look how busy it is. There's all the work is being done here. There's no gaps, so we know it's not really work being done on the background thread that's just taking up a lot of time. And now for the last part here, it says for the summary, it says you have now reproduced the hang, which we did, and we learned what it feels like and more clearly seen the impact that it has on the user experience. Yeah, this is horrible. So we saw how basically whenever we have a hang, the user might interact with some button or some view in the app, and basically they'll just be left in limbo. One, they can't click anywhere on the app. So let's run this. Open this again, and we have to switch back to our run button, and it runs it. And it's a crazy hang. So when we click on collection now, the hang starts, and one, we can't click on anything in our current view, and it's taking us forever to go back to our experience. This is a horrible experience for the user. There. All right, let's go this. And then I'm more clearly seeing the impact it has on the user experience. Excuse me. You can also record, you also recorded the hang in instruments, so you could measure its duration and analyze it further. Yeah, so we recorded it here. We just hit record, and then when we hit the record button, first we have to profile, and then we hit the record button, and basically it launched the app, and then we pretty much went through the app and then went to where we're seeing the hang, and we're able to capture that. The instruments was able to capture all the processes happening on the background under the hoods for the app, and we could see, could add different instruments to check for. In this case, we choose a time profiler to check the CPU usage. And after recording, we could see certain points where we have certain points in the app where we have the CPU using doing a lot of work. So right here you see it's like 90, 116, which is, as I said, the max for a core is a CPU usage is 100. So right now we can tell they're using one core, and probably they had to slip into using a bit of another core for 120%. And then it says, by the end, you were able to determine that this specific hang is the result of a main thread doing too much work, which is a busy hang, a busy main thread hang. Next, you learn how to analyze work on the main thread. So for the next one, it looks like we're going to be focusing on next analyzing main thread activity. And it says, knowing what's happening on the main thread is essential to understanding hangs. Essentially, especially for busy main thread hangs. This tutorial guides you through doing an initial analysis of the CPU usage on the main thread. So I guess in the next stream now, we're gonna handle this chapter where it's gonna focus on basically finding out more about the hang issue that we might be having on the main thread. Yeah, so we'll pause the stream right here. If you like this, definitely subscribe and follow. In the next stream, we're gonna focus on analyzing it, and I'll try to include. I will include pretty much the URL for each of the chapter tutorials that we have. So again, all right.